on strings or tension and inclined plane. Okay. So if string can be either rope or thread, anything attached between two masses. Okay. For example, this is the floor, ground. On this ground, there is a box of mass m1 and there is another box of mass m2. Both are being attached by using a string, and this is being pulled by using a force of F. So now what will happen here? In between these two ropes, there will be a tension. As we are pulling here, this block will pull this block. So tension will be there by this block on this and this block on this. And as the rope is same, tension is same. Okay? As the rope is same, tension will be same. What does I mean? If I take like this, instead of two boxes, three boxes. Here one box, here one box, here one box. All are being tied by using rope. Here I am being pulling with force F. Here mass m1, mass m2, mass m3. In this case, here there will be a tension of T1, here there will be a tension of T2, and T1 is not equal to T2 because these two are with same rope, but these two are with same rope, but m1 and m3 are not with same rope. So if the ropes are different between the masses, then tension will be different between the masses. Clear? Understood? If masses are different, tied by different ropes, then we'll have different tension. Okay, now let us see how to find tension on this string. How much is the tension? Now when I am pulling this, then as the body will move this side, because I am applying force, the body should move along force direction. Then both will move with uniform acceleration. Both will move with uniform acceleration. Let us take the acceleration with which both the bodies are moving are with A. Okay, now if I take free body diagram for M2, force will be F. Okay, and tension will be this side. Body is moving with acceleration A, mass is m2. Now tension is less than force because we are applying this side, acceleration is this side. So net force will be force minus tension. Correct? Net force is nothing but total force. With what force this body will move? This body will move by the subtraction of these two forces. Correct? F1 is greater than F2. F is greater than T. So F minus T. Now what is net force? Net force is nothing but mass of the body into acceleration. That is equal to F minus T. F minus T. Now if I take M1 block. If I take M1 block, here there will be a tension this side. Tension will be this side, and this side nothing is there. Only body is moving with an acceleration. Then what is our net force? Net force is nothing but only tension. With the tension force, there is a body moving. The body is moving only with the tension forces, or no? Therefore, net force will become tension. What is net force? Net force is nothing but mass. According to Newton's second law, net force is nothing but mass into acceleration for a uniform accelerated body. Therefore, tension here it will become M into A. Tension here it will become M1 into A. M1 into A. So if you know M1 mass and A, you can. So to get A, to find A, substitute this M1A in place of T. Then what will happen? M2 into A is equal to F minus, what is T1? What is T? M1 into A. From this, F is equal to M1A plus M2A. From this, what is A? A is nothing but F by M1 plus M2. F by M1 plus M2. Understood? Understood or not? Here, now you have to substitute this acceleration here to get the tension from this. How much tension is there? That is equal to M1 into, in place of A, you have to put the acceleration value M1 plus M2. Understood? E is equal to M1 into, in place of A, you have to put F by M1 plus M2. This is the tension which is acting on this string. Okay, now. Clear? Shall I go for next or are you copying? So can you tell what is the acceleration and tension for this second one? Can you please tell what is the acceleration and tension for the second one? Here we found acceleration and tension in this first one. For two system. This is called two body system. Two body system. Here it is three body system. Now for this three body system, can you find acceleration and tension? What is the formula for three bodies? Here, see here, for M1, net force will become only tension. Here M1 into A is equal to T. For the second block, for M2, okay, this is applying T1 tension this side. This is applying T1 tension. So T2 net force will be equal to, net force is equal to T2 minus T1 because the body is moving along this direction. T1 will be less than T2 for this body. So T2 minus T1. Net force is equal to T2 minus T1. Okay now. So from this, net force is equal to T2 minus, in place of T1 it is M1 into A. M1 into A. Here we will get two different tensions. Not just T. Now what about third block? M3. Third block means M3. For M3, F net will be equal to F minus T2. F minus T2, right? Because this side tension T2 will be there, this side F force is applied and the body will be moving with acceleration E, then net force will be equal to F minus T2A. Here F net means what? M2 into A is equal to T2 minus M1 into A. Here F net means what? M3 into A is equal to F minus T2. F minus T2. Now from this, what is T2? From this T2 is equal to M1 plus M2 into A, right? So if you substitute the T2 value in this, then F will become M1 plus M2 plus M3 into A. From this, what is A value? F by M1 plus M2 plus M3. Here just one more mass will be added for acceleration. Okay now, but tensions are two different tensions we will have. How many tensions we will have in this case? Two different tensions we are having in this case. So we have to find two different tensions, T1 and T2. So T1 is nothing but M1 into A. And what is A? A is nothing but F by M1 plus M2 plus M3. Okay. Then what about T2? T2 is nothing but M1 plus M2 into A. Here we got from this. So what is A? A means F by M1 plus M2 plus M3, correct? Now observe here. For M1 nothing is there at the back side. Therefore only M1 F by M1 plus M2 plus M3. For M2 we have M1 at this side. Therefore M1 plus M2. Understood? So if you see, let us take this one as F1. Let us take this one as F2. Here F1 is greater than F2. F1 is greater than F2. Therefore body will move along this direction. So acceleration will be this side. So if you take for this one, for 15 kg, here force is this side, tension is this side. Let us take T1 here, T2 here. Okay. Then here T1 will be greater than T2 because this force is not applying. Tension is more than. Here F2 is less than T1. Therefore, net force will become for this T1 minus F2. For this 10 kg, net force will become T2 minus T1. For this 5 kg, net force will become 90 F1 minus T2. F1 minus T2. Tension will be this side for 5 kg. So from this, T1 is equal to F net is nothing but 15 into A. 15 into A plus F2. Where F2 value we know. F2 value is 30 Newton here. In this case, F net will become 10 into A. That is equal to T2 minus T1 value. We will write it as 15A. We will write like this. F net 10A is equal to T2 minus T1 is 15A plus 30. Then from this T2 will become 10A plus 15A minus 30. That is equal to 25A minus 30. That is equal to 25A minus 30. Okay. So coming to here, in this, F net is nothing but M into A. That is equal to 90 minus T2. T2 value is this one, 25A minus 30. Then it will become 5A is equal to 90 minus 25A plus 30. If you bring this 25A this side, 25 plus 5, 30A is equal to 90 plus 30, 120. 0, 0 cancel. 3 table 4 times. Acceleration is equal to 4 meter per second square. Now put this A value in this, then we will get T2. T2 is equal to 25 into 4 minus 30. 25 into 4 is 100. 100 minus 30 is equal to 70 Newton. Now put this T2 value, put this A value in this T1. Then T1 will become 15 into 4 plus 30. 15 4s are 60. 60 plus 30. That is equal to 90 Newton. So T1 is equal to 90 Newton. T2 is equal to 70 Newton. Correct? Understood? There is a block of mass 4 kg, 2 kg and 1 kg with a force of 14 Newton. With a force of 14 Newton. Consider here tension as T1. Consider here tension as T2. Now find T1 and T2. Find T1, T2 and A values. Start now. Okay. Then you do. Equal to 2 meter per second square. Yes. Correct only, madam. Directly you can substitute here. First A you can find here. What is A value? A is 14 by 7. 7 table 2 times. So this value is A. So M1 plus M2. 4 plus 2 into 2. That is equal to 6 into 2 is equal to 12 Newton. Here M1. M1 is 4. 4 into 2. That is equal to 8 Newton. This is 2 meter per second square. Formula, how it will be same? Both sides there are forces F1 and F2. Then what will happen? Acceleration. Acceleration formula is F net by M1 plus M2. Here what is the net force now? Net force is nothing but F2 minus F1 by M1 plus M2. Now what about here T? T is equal to anything. You can take this or this. Okay. T will become M1 or M2 you can take and you can solve it. For T, 50 minus T is equal to F net. For this, if you take with this, then 150 minus T is equal to F net. Is how A will become 1 by 6. A is equal to 150 minus 50 by 20 plus 30. 100 by 50, that is equal to 2 meter per second square. Is how from this T is equal to 50 minus F net. F net means F net is nothing but mass into acceleration. Mass is 20, acceleration is 2. 50 minus 40. Sorry, T is equal to 50. Sorry, here this side T minus 50, not T. Understood? Why? Because this is greater than this, not 50 minus this. Okay, T minus 50. T minus 50 means you have to add here. The same you will get answer here also. Minus T is equal to F net means 30 into 2. T is equal to 150 minus 60. That is equal to 90. Same answer you should get for both. Yes or no? Understood how to solve this type of questions? This one you have to convert it as T minus 50. This side it should be T 50 because T is greater than 50 as this side is more. Next topic is, instead of string we are using a spring. Okay, spring based problems. Let us solve today now. Spring based problems on the same topic. Okay, see actually how we will have a spring. Let us take, this is a rigid support. For this rigid support I have a spring like this. Now this spring is attached to a block of mass M and this block is at rest. When this block is at rest, there is no force, the distance is 0, means this is at rest position. Then this will become origin. Okay, this point will become origin S. So now what we will do in this case, now let us stretch the spring. let us stretch the spring to this distance. So what is this point? This is x is 0. Now where it has been moved? This block has been moved. Okay, let us consider this one. Yes, this block has been moved till here, right? If this one is considered as 0, this line, then this one will become displacement. Let us think that x distance it has been displaced. Okay, how much distance it has been displaced? X distance. Okay, how it has been displaced? Because we applied force F. Before the force is 0, now there is a force. Yes or no? Understood? Now if you leave this block, again after moving, it will come back to rest position. Yes or no? This is called, in this position what happened? Spring is been pulled. In this position, see here, this is origin. Now what we did here, instead of stretching, we compressed the string, and now this one we call it as x distance. We have compressed it. Okay, now this is compression, this is expansion, right? Now how much distance is displaced is based on the force what we applied. Therefore force is directly proportional to the, yes or no? Force is directly proportional to the displacement. Force is directly proportional to the displacement. But force is in this direction, displacement is in opposite direction. Yes or no? Therefore we take it as F is directly proportional to minus x. From origin it will be displaced to negative, opposite, force will be opposite to the, see, force, what the spring will apply force is this side. Yes or no? When I stretch, force will be this side. When I compress, force will be this side. Correct? Therefore when I leave, this block will move this side. When I leave, this block will move back side. Correct? Are you understanding? మనం లాగినప్పుడు స్ప్రింగ్ వెనక్కి పోవాలని ట్రై చేస్తుంది, మనం ప్రెస్ చేసినప్పుడు స్ప్రింగ్ ముందుకు రావాలని ట్రై చేస్తుంది. అంటే ఆపోజిట్గా మన డిస్ప్లేస్మెంట్కి ఆపోజిట్గా ఫోర్స్ ఉంటుంది. సో ఫోర్స్ ఈజ్ ఆపోజిట్ టు ది డిస్ప్లేస్మెంట్. Therefore force is directly proportional to minus x. Minus indicates that spring force is opposite to the displacement. If I remove this proportionality, I have to put some constant k. Therefore this will become F is equal to minus kx. This is known as the spring force. What we call this one? Spring force. The force inside a spring is minus kx. This is also known as Hooke's law. This is also known as Hooke's law. According to Hooke's law, force is directly proportional to the displacement for a spring, and this force is known as restoring force. What we call this force? Restoring force. అంటే మళ్ళీ వెనక్కి వచ్చే ఫోర్స్ ని రిస్టోరింగ్ ఫోర్స్ అంటాం. Clear? Understood? And what is this K? K is known as a spring constant. K name antam spring constant. Therefore K value will become F by x. K value will become F by x. So what is the unit of spring constant? The unit of force is Newton. Unit of displacement is meter. Therefore the unit for spring constant is Newton per meter. Newton per meter. Then what is the dimension for the spring constant? Dimension is Newton is nothing but force. Force is ml t power minus 2, and 1 m is there down. So plus 1 minus 1 will become 0. So m power 0, l power 1, t power minus 2. So numerical on spring. Let us take force constant of a spring is 1000 Newton per meter. If a 10 kg block is attached to the spring, is in equilibrium. If a 10 kg block attached to a spring is in equilibrium, then find the extension of the spring. So from equilibrium, if you place it and if you leave it, it will extend. Then what is the extension? So this extension is nothing but x. Extension means x value we have to find. X value we have to find how much it will extend. So extension can be known by using what formula? F is equal to k into x. F is equal to k into x. So here, whenever there is a spring attached to this weight is equal to the force. Yes or no? How much force is equal to its weight? Therefore, in place of F, we can write weight. Weight is nothing but m into g. Weight we can write it as mg. Weight is equal to force. Weight is nothing but m into g. Force is nothing but spring force k into x. Now, what is x value? M into g by k. What is your mass? 10 kg. What is g value? What is g value? You can take it as 10 by k. K value is how much? 1000. So if you cancel two zeros, that will become 1 by 10. 1 by 10 is nothing but 0.1 Newton per meter. Okay. So x value is equal to 0.1 Newton per meter. Understood? No, sorry, extension, no? We will not have Newton here. We will have just a meter because it is distance. So x value is 0.1 meter. What is x value? 0.1 meter. This much it will extend. One more numerical. What's on there? There is a 10 kg here attached to a spring to a 20 kg mass. Now this 20 kg mass is being pulled with a force of 200 Newton. So two masses are there. This is mass M1, mass M2, 10 kg and 20 kg respectively connected by a massless spring. So this is a massless spring. Now force of 200 Newton acts on the 20 kg mass. So 200 Newton force is acting on 20 kg mass. At the instant when 10 kg mass has an acceleration of, this 10 kg mass is moving with an acceleration of 12 meter per second towards right. Then towards right means this side. Then the acceleration of 20 kg mass is. So what will be the acceleration for the 20 kg mass? Okay, because this is spring, acceleration will be different. For spring different, for string same. So if it is a string, both will move with same acceleration, but this is a spring. So what will happen? Both will not move with same acceleration. So this one, let us take it as A1 acceleration, A2 acceleration. Now at 12 meter per second, what will be the acceleration for 20 kg mass? Okay. Now let us take free body diagram. Okay. Let us take free body diagram for 10 kg mass. So this is a 10 kg mass. Okay. This side, what it will have? Tension will be there. This side tension will be there. Okay. And acceleration will be this side. That is 12 meter per second square they gave. Okay. Then what will be the tension? Tension means here force. Here tension and force both are same. Don't forget. So here what is force? Force is nothing but mass into acceleration. So what is mass? Mass is 10 kg. What is acceleration? 12 meter per second square. Then what will be the force? 20 Newton force will be there, or 20 Newton tension will be there on this string. Okay. Now for 20 kg mass, what will be the tension? So let us take free body diagram for 20 kg mass. So for 20 kg mass, here we are applying 200 Newton this side. Tension will be this side now. So tension is how much? This side. This force. Tension and force are same. This side what will be the tension? 120 Newton. Then what will be the net acceleration? Net force is equal to how much? F minus, or F, instead of F we can write this one. Yeah, net force is equal to 200 minus 120. That is equal to 80. Net force means mass and acceleration. Mass is 20, acceleration is 12 meter per second. Sorry, we want acceleration now. Sorry. So here acceleration A. Now acceleration is A is equal to 80 by 20. 0, 0 cancel to table 4 times. So acceleration is 4 meter per second square. So when there is an acceleration for this block 10 kg 12 at the same time, same instant, for 20 kg acceleration is 4 meter per second square will be the acceleration. Okay, so let me draw the picture. So this is rigid support. Here there is a block of mass EM A, block A. For this block A there is a spring attached, and here we connected another block of mass M, because both are having same masses. So both are having M and M. Here there is a block A and here there is a block B attached with a light spring. Find the acceleration of block A and block B when we cut the string. So this is string. We cut the string, then both will move. Here both will not move with same acceleration, because both are attached to string. When both are attached to spring, my acceleration will be different. So acceleration of A is how much and acceleration of B is how much. Will you solve? Solved. First you have to take free body diagram for B as well as for A. If you take B, for B there is a mass M. Tension will be upwards for this, because this block when it is going down, this spring will move, pull up. So tension will be upward. Okay, weight will be downward. For block A, what will happen? See, weight will be downward, tension also will be downward, and both are connected with same strings, tension will be same, but acceleration is not same. Okay, now here for A here one more tension is there. Let us take this one as T1. Okay, that tension will be upward. Okay, now as we cut the string, this tension will become 0. There will not be any tension by this string because we cut this. Correct? So for this, what will be the formula? Weight is more than tension. So this tension will be equal to weight. This tension will be equal to weight. Here what will happen? This tension is equal to weight plus tension, T. T1 is equal to W plus T. Here W means M into G, mg. T will become mg. Here T1 is equal to M into G plus mg. Total this will become 2mg. This will become 2mg. Okay. Now when we cut the string, what will happen? Instead of G, it will move with acceleration. Plus mg, this tension will become 0 because we cut the string. As we cut the string, there will not be any tension for this one. This will become 0. and this weight will become mass into acceleration. Okay, tension will become mass into acceleration. So this tension will become mass into acceleration, weight will be m into g. So this acceleration is acceleration for the block A. Acceleration of the block A. Here this tension will become net force mass into acceleration of block A. So acceleration of block A is nothing but tension by mass. Okay, acceleration of block A is nothing but tension by mass. In this case, what will happen? See, as tension is becoming 0, here acceleration also will become 0 for this block A. Okay, let us see once again. I am taking here new diagram for understanding. This is block B. For block B, tension is equal to m into g and downward m into g. Okay, in this case, when it is freely falling body, acceleration becomes 0. For block A, weight mg will be downward, tension also will be there, that is also equal to mg, and there is a tension T1. Okay, as this is 0, now with the acceleration is equal to sum of this. Means acceleration will become here in this case, net acceleration for block A is equal to net force, that is equal to tension plus weight, means mg plus mg, 2mg. Here 1m cancel, A will become 2g. So what is the acceleration of A? 2g. And what is the acceleration of B? 0. Understood? Going downward. Understood? Next one is smooth inclined plane. Okay. So how will be an inclined plane? An inclined plane will be like this. There will be an inclination from the ground of theta degrees. If we have a body of mass m, block m, and here. Okay. Now if you see for this, if you take like this, weight will be downward. Okay. Here, as this is making an angle theta, this weight will be resolved into two components. So as weight is been resolved into two components, this side it will become mg cos theta and this side it will become mg sin theta. Downward mg cos theta, this side mg sin theta. As it is being smooth inclined plane, body will move downward. If you keep any body upward, it will come downward. Okay. So now if you see up here, perpendicular force means for this surface the perpendicular force is known as normal. So normal will become mg cos theta. Okay, net force will be equal to what will become net force? Net force is nothing but mass into acceleration. Okay. Here we don't have any acceleration along y-axis, 0. So it will not move up and down. Only acceleration along x-axis. Clear? And acceleration along x-axis we are taking it as A. So force is equal to mass into acceleration. So this net force is nothing but force is this one, mg sin theta. Mg sin theta is equal to m into A. With this force, this body is moving downward. Okay. So what is acceleration? Acceleration with which the body is coming downward is g sin theta acceleration. What is acceleration? G sin theta acceleration. Clear? Understood? This is weight. Weight is nothing but force. This force is resolved into two components. So with what force it is going to come down? With mg sin theta. So this force is equal to net force of the body. Net force of the body m into A is equal to mg sin theta. From this, acceleration with which the body moved downward is equal to g sin theta. Understood? Yes. Let us do one numerical. So here there is a inclined plane which is at an angle theta. There are two blocks M1 and connected with another block M2. Okay, I am pushing it upward. Okay, let us take three blocks here. Let us take M2 block, M3 block. Three blocks are there which are been pushing upward. Okay, then what is the force between M2 and M3? What is the force between M2 and M3? Here, what will be the force? So, what will be the formula here? Acceleration is nothing but, see, this is inclined. It is just inclined. If you forget about inclined, three body system. For three body system, what is acceleration? F by M1 plus M2 plus M3, right? For inclined plane, what is the acceleration? G sin theta, right? Understood? For inclined plane, acceleration is G sin theta. Okay? If you take three body system, acceleration will become F by M1 plus M2, M1 plus M2 plus M3. But instead of acceleration A, we will take G sin theta because it is inclined. And the formula will become this. Understood? Clear? So from this, what is the force with which it is come down or it will move up? That is equal to M1 plus M2 plus M3 into G sin theta. Okay. If I want force between these two, what is the formula I should apply? Between M2 and M3, or the tension? Tension between M2 and M3 is M1 plus M2 into acceleration, correct? If I want between M1 and M2, then tension will become M1 into A, right? So in place of A, what is right? G sin theta. In place of A, what do you write? G sin theta. That's it. Clear?